G'day, my name's Matthew Allford and we're here at vForum in Sydney, and I'm here to talk to you about using a vSphere project, the Vesta project to enforce a vSphere configuration. There's a couple of my details there. Hit me up on Twitter, and I work for a VMware partner, VIFX. So before we get into the Vesta project itself, I've just got a quote here that's around using the mentality of infrastructure as a code, and it's nothing new, but there's a lot of people that are still not in this mentality yet and doing a lot of ad hoc remediation to their environment. So this is pulled straight from Wikipedia. So infrastructure as a code is the process of managing and provisioning computing infrastructure and their configuration through machine processable definition files, rather than physical hardware configuration and the use of interactive configuration tools. So for me, what that translates to is being able to specify or retrieve a configuration of the environment in a declarative model using a simple standard that's painless to maintain and understand. And that's one of the key things. So what we want to end up with is using a single tool or system to be able to define the environment configuration. What do we want our desired state to actually be? We want to test on that and get a report for the configuration drift. Where am I not in my desired state? But then importantly, go and fix it for me. I don't want to have to manually go in and enable SSH on a host or disable or get that back to a desired state manually. So that's where Vesta comes in. So Vesta is a community project that was kicked off by a guy that probably everyone knows, Chris Wall. He kind of put it out onto GitHub a little while ago, but he's only started talking about it recently, and there's a few guys who are doing a lot of really good work there. So that's the statement there as to what Vesta is from the GitHub project. So it's a community project that aims to provide a lightweight approach to the vSphere configuration management using Pesta, which is another community project, and PowerCLI. So what are the requirements for getting it going? You want to grab PowerShell version 4 or later, PowerCLI 5.8 or later. Recommendation is always to run the latest version of PowerCLI. It's backwards compatible. I think the latest version goes right back to managing vSphere 5 from memory, so grab the latest. And the third thing you will need is Pesta. So for those that don't know, Pesta is a community project as well that's essentially a framework for running unit tests, and it can validate the PowerShell commands, and then it'll give you a result as to how your test went. And then from there, you can do something with that if you want. So that's the GitHub page there. You can see on the branch there, I'm looking at the module at the moment. If you go there as of right now, there's 2 branches. The master one's kind of some older stuff, and no one's really working on that anymore. Everyone's working on the module, and the module will no doubt soon become, the master of the project. So you can grab it from there, just download it. So this is just a quick run through of actually installing it. So you can download and install Pesta from GitHub. I'll have a link at the end for Pesta. It's just copying the folder into the PowerShell modules folder, and then you've got it ready to go. Same with Vesta, download it. And what Chris has actually done is he's got an install vesta.ps1 script, which we can see there. And so if you run that one, essentially what it'll do is it just copies it into the correct folder for you. So by default, it'll copy it into the Vesta folder under modules for the user profile. So there we can see that it's actually copied everything down under there. So for the sake of a couple of demos that I've got, I'm grabbing the configs folder and the test folder out of that and pulling them into C scripts Vesta for me, just because I have to type a couple of paths in the video, so it's a bit easier to get to there. So if we have a look inside the configs folder, by default you'll have config.ps1 and then you'll have config.test.ps1. Now anything that's a .test file is a Pesta test. Config.ps1 is where we're going to actually define the vSphere configuration and the environment. That's how we want it to look. That's what my NTP servers are. Do I want SSH enabled or disabled? Should I have HA enabled on the cluster? Those kinds of things. You can create multiple config files for multiple environments. So if you've got a couple of different vCenter servers, or if you want to, segment that out for prod or dev or whatever, you can go ahead and do that as well. So as mentioned, config.test.ps1 is a test file written by use for Pesta. And the invoke Vesta module inside actually calls under the hoods invoke Pesta, which is how the whole thing kind of bolts together. So running a pester test against that actually confirms that the data that you've put inside the configuration file is valid. So you haven't gone and fat-fingered something in there, you haven't put a string where it expected an integer or something like that. So I got the first demo, which is a recorded video. So I'll bring that up. So we're going to have a look at the config file and then at the pester test as well and the output of that. So this is just where I've copied it into, C scripts and Vesta. If we jump into the configs folder, we've got those two files that I talked about, config.ps1 and then the pester test to test that the config is actually correct. So I'll jump into the IC and we'll have a look. And so the first file we're looking at is config.ps1. So the way it's written at the moment is we've got a hash table there in PowerShell, and then throughout the rest of the document we've gone and defined keys and then values for those. There's a bit of help in there as well for each kind of block of section, so you can see what you should be putting in there. So if we have a look at the scope, for example, that's saying what do I want to run my tests against in my environment. So asterisk or wildcard means everything for now. If I wanted to, I can jump in there and just run it against my cluster called cluster 1, if you wanted to do that. The next one we've got down is the vCenter server settings themselves. So what vCenter server do I want to connect to and run this against? A bit further down we've got some cluster settings, so the DRS mode, so that's the fully automated, partially automated, manual, and then the DRS level, so how aggressive do I actually want to be with my DRS. So I won't go through the rest of the file, but that's how it's laid out for the config file. So you can go in, manually define that at the moment. There's a pull request in at the moment to actually go and retrieve that info and pull it down into a config file, which is JSON, so that's pretty cool as well. So if we look at the config.test file, so this is the pester test, but in short it's just a PowerShell function. So it requires pester and it requires the VMware modules as well. So at the top there in that first block we've got just standard PowerShell parameters defined, and by invoking Vesta these are automatically passed through into this, so you don't need to worry about that too much. We've got a process block that kicks off for the main PowerShell script. That's just pretty standard again. Now this describe that we've got here, that's pester lingo if you like. So a describe is a kind of a block of tests that you want to run. So we're saying that we want to validate the config file. That's the description that we've got here. And then we've got an IT, so that's an item, so that's an individual test. So each IT that's listed under the describe is what we're actually going to run a test against. And that's going to give us a result as to whether it was passed or it failed, and if it failed, why did it fail. So if we have a look at the particular test for the cluster there, we've got it's what it's saying is that the amount of keys that we've defined in the config file should match DRS mode or DRS level. So if we jump back to that, we can have a look. We've got DRS mode, we've got DRS level. We should have two keys, which are both those that we've just talked about. The value should not be empty. We want to actually define something there. The DRS mode should match fully automated, manual or partially automated, and the level should be an integer, and it should be 1 through to 5. So in a nutshell, that just goes and confirms that the config file that we've got is not going to have anything that's going to screw up our environment if we go ahead and run this to remediate. So I'm going to jump across now and do a quick demo of actually running the config.test, pester test, against the config file, and I'm going to go and break it, and we'll see what the error is, and we'll go and fix it. So we can use invoke Vesta, and the parameters there, we've got a -config, so we point that at the config file that we want to test against or that we want to run. And there's a -script parameter. I don't like that. It maybe should be tests or something, but that's essentially saying give me the folder that you want me to run all tests underneath it, and those tests are the .test files. So if we go ahead and if we go ahead and run that in a minute, see what that does is at the top there in purple we can see that it's got the describing config file validation. So that was the describe block in the test, and then it's got each item test in green underneath it. So it's all green there, which is obviously a good thing. At the bottom we can see it completed in 1.17 seconds, and we've got 9 tests that have passed and 0 that have failed. So at this point in time I know my config file's good, I've got good data in it, I've done a test against it, and we're ready to move on to actually going ahead and testing the environment itself. So I'm just going to go back into the config file quickly, and I'm going to break one of the settings. So instead of having a fully automated DRS mode, we're going to have fish. So we don't like that? Don't know. And we're going to go ahead, run the test again, and this time we'll see a failure. It might be a bit hard to see there, sorry, but what it's saying there is it expected fish to match the expression fully automated, manual, or partially automated. So it's told me what's actually wrong. And next line down, DRS mode should match one of those three settings, and it didn't. So someone's fat-fingered my config file, need to go back in and fix that up. So it's actually telling me down the bottom in the summary now that I've got one failure as well. So I'll jump back in there and fix that up. So that's the config side of the Vesta project. And I'll jump back across. I've got, we'll have a look at the actual tests themselves now. So we had that config folder, and now we've got the test folder. So underneath the test folder, everything's kind of segmented out into its own folder. I think it's pretty similar to vCheck if you've used that before. And inside one of the section folders, so I've jumped into the cluster folder here, and we can see that we've got an update-drs.test.ps1 file. So this again is a pester test, and it's going to test if my DRS settings are correct in the environment or not. So I'll jump back to the second demo. Which I think actually kicked off a little bit. So that's the test folder there, and inside that, the ones we just saw in the screenshot. And we'll jump into cluster, and at the moment there's one test in there, which is the DRS test. So we'll jump into the IC and actually have a look at how that's built, and then we'll run it, and we'll see what happens. So again, it's just a PowerShell function, pretty similar to the test for the config file. Now, what's important here is that one of the parameters that we've got there on line 7 is remediate, and we've set that to false in all of the tests by default. So what that means is if I run invoke Vesta, it's not going to go and do anything to my environment by default. It's just going to report on it, which is good. If we set that to true back in invoking Vesta, it'll pass that parameter through to all of the tests, and it'll go and fix the environment if that's what we need. And the other ones there are just passed through by the invoke Vesta module as well. So similar to before, on line 16, we've got the process block that kicks off for the PowerShell script itself. Line 18, we're describing the tests that are going to be run under here, so that's the purple block that we saw before. And now the variables that we've got on the next line down are pretty important. So on lines 20 and 21 here, we've got DRS mode. So I'm grabbing an empty variable, and then we're looking at the config file, which is $CFG cluster DRS mode, and I'm pulling that from the config file back into that variable, so I can use that later in the test to see if my environment has drifted from what I defined back in the config file. So same for the DRS level there as well. Store that in DRS level, and then we'll use that in one of the tests in a few minutes. And then we just kick off a for each loop. So if we had multiple clusters in the environment, mine's only got one, it'll go through each cluster and it'll check for these desired settings. So after the for each, we kick off into an IT, which is one of the pester tests. And so this is a reasonably sized test. It goes down to line 47 there. And what we want to do there, so we've called it cluster DRS mode. So we want to test that the mode is valid. And what we're doing here is we're creating another variable again, $value, and we're going to the live environment, and we're doing a get cluster for the current cluster in the for each loop, and we're pulling out the DRS automation level, and we're storing that in $value. And then underneath that, we kick off a try and catch. So for those that aren't familiar, it's a pretty standard kind of error handling. We want to try something. If it worked, awesome, return the result and go ahead. If it failed, we want to catch that, and then we want to do something with it. So what we're going to do is we're going to try to see if $value, now that should be $DRS mode. So $DRS mode is what we pulled from the config file, and $value is what we've pulled from the live environment. So we obviously want those to match. If they don't, we've drifted from our desired configuration. So if that matches, we'll get a green pester test. If not, we'll move on to the catch block. In the catch block, if we've got remediate set to true, which it's not by default, but if we do have it set to true, it'll go ahead and run that bit of code there. And what it's going to do is it's going to write me a warning. It's going to say, hey, your environment is not how you wanted it to be, and I'm going to go ahead and fix that for you. So I'm just going to run a set cluster against the current cluster in the for each loop, and it's going to change the DRS automation level to what I've defined in my config file, which is $DRS mode. And after that, that'll output to screen, which we'll see here in a sec as well. If we didn't have remediate, it moves on to the else block, and it just throws the error as to what actually failed in the test, so we can see that from there. So that's the first test in the DRS tests. And the second one that I've got down there, I won't go through it all. I might need to skip a bit in the video here. But the second one tests for the automation level. So same framework again, goes to the live environment, looks for the automation level, which is the 1 through 5, how aggressive do you want to be, and grabs $value, compares that, and goes from there. So I think we're not too far off there. Might just skip ahead. Yep, so we're going to go ahead and I'll run this now. So what I'm going to do is I'm going to invoke Vesta config file, pointing it back to the same config file that we had before. But this time the script is pointing at the test cluster folder. So it's going to run every pester test that sits underneath that folder, which in this environment is just one. So I'll go ahead and run that test and we'll get an output to screen. So we've got the purple there, which is the high level, what am I running? And then the green is each individual test. So at the moment, my DRS mode and automation level's good. Both were green. Down the bottom, 2 passed, 0 failed. It's looking good. So then Dave comes along. It's always a Dave. He wants to set his environment, or the DRS mode, and he's going to turn it off. He might be doing some maintenance or adding a host, doesn't want something to move on there. So he's gone and set the cluster, and he's changed my DRS automation to manual, which is drifted now from my desired configuration as to how I wanted it. So if we run the same invoke Vesta again that passed a minute ago, we see a failure here. And what it's saying is that I expected it to be fully automated, but it was manual. So someone's gone ahead and changed that on me, and it's flagged it here. And now I've got one that's passed and one that's failed. So I've drifted from what I wanted. So what we can do is we can put -remediate on the end and set that to true. And we can run that, and what that'll do is it'll pass that remediate through to the test, which will go and run that set -cluster that we saw before. And now it's giving me a few warnings. It expected fully automated, but it was actually manual. I've gone ahead and fixed that for you, and I've run the tests again, and they've both passed now. So being able to run that, not having to go into the UI or PowerShell, remember the exact commandlet and syntax, I've been able to determine that my environment drifted from its configuration and fixed it with running invoke Vesta. So I think Chris Wall had an interesting story. He looks after the labs at Rubrik, I think, and he essentially uses this, schedules it to remediate true, and it'll fix his environment, every 3 hours, every 1 hour, or whatever. So people are forever in a lab and that changing it. So that's pretty much it. The project. I'll just flick it back across. So just in summary from start to finish. So you want to download and install Pester, which is the testing framework that Vesta uses to validate if something's passed or failed a test. Download and install Vesta, the module. Define your environment configuration in the config.ps1 file located in the configs folder. And as I said, there's a new pull request in which came in on Monday night actually, so today's Wednesday. And I recorded those videos on Monday, and as I was recording them, one of the guys who's done some awesome work on this project put in a massive pull request to GitHub, and it's kind of gone and changed what I've just shown you there. So I think that's correct as of right now, but that's the way community projects go as well. There's some really good guys doing some work here, and it's changing pretty rapidly. So that's IT. So once we've gone and defined the configuration, run a test to make sure your config files, the data that you put in the config file is valid. Run invoke Vesta against the test folder to run the tests that you want and get a report of where your environment's drifted, and then you can run it with the remediate parameter to go ahead and fix your environment for you. So if you can, I'd suggest getting involved. The tests aren't too hard to write. There's kind of a template there in the GitHub project. If you know how to check for a setting in PowerCLI and then set it to something else, you can pretty much write a test there pretty easily. And if you submit the pull request into GitHub and there's something wrong or it can be done better, the guys are really good at helping you out with that. So that's it. There's a couple of links there off to Vesta, Pester, and there's another project that I haven't had time to check out, but I've read about it and it looks quite good, and that's vSphere DSC. So it uses the PowerShell desired state configuration or DSC framework. So it's kicked off by Luke Deacon. So if you've ever Googled anything to do with PowerCLI, I guarantee you've ended up on his blog or you've ended up on a forum where he's got the answer. So that's another project that I'll be checking out as well. So yeah, thanks to all the sponsors there, and for vMug and the vBrownbag crew for putting it all together and having me here.